Okay, so, law of conservation of matter. Now, the main thing here is the word matter. The reason that the word matter is in here is because matter is the basis of everything in the universe. This tree, it's made out of matter. The ink and the marker, made out of matter. Everything that you can see, touch, and feel is made out of matter. Now, matter can neither be created nor destroyed except at two certain points in the universe. The only place where it can be created is at the center of the universe, which is also known as the Big Bang, which is technically still going on. And the reason it can't be created or destroyed. You might say, well, Jack, what happens if a bomb goes off? Well, what happens when a bomb goes off is that all the matter goes from all nice and organized, like little buildings and houses and stuff, to and all off in the air and stuff. The matter is all still there, it's just extremely scrambled. The only place in the universe where this theoretically does not apply would be a black hole, but I'm not going to get into that. Now, the reason that you have to care about conservation of matter is doing a chemical reaction, like, say, photosynthesis. CO2 plus H2O equals C6H12O6 plus 6O2. And now you might say, wait, there's not enough atoms in here to make this. Well, that's why we have to have conservation of matter, is because that's how we get into balancing equations. Since we have conservation of matter, this is not enough to make this, so therefore we need to balance the equation. And an easy way to balance an equation is by seeing how many total atoms are in the product. And so, how you do that is, 6 CO2 plus H2O equals C6H12O. So the first thing you want to do when you're balancing an equation is break down each individual atom that's in here. So here I have oxygen and oxygen, so I have 3 O's. I have hydrogen, so I only have 2, so 2 hydrogen. And I have carbon, and I only have 1 carbon. Well, on this side, I have 6 carbon, 12 hydrogen, and 8 oxygen. And so what I want to do to balance this is I gotta make it so that the total number of atoms on this side is equal to the total number of atoms on this side. So, the way that works is by putting a pre-number in there. I don't really know the exact name, but you just put a number in front of it, which means that's how many of this molecule you'll have. So, the easy way to balance this equation is 6CO2 plus 6H2O equals blah, blah, blah. But if you break it down and do it the mathy way, which is how you have to do for a more complex equation, then it goes like this. So you want to find the smallest number of atoms you have first. This. You have 6 carbon, and then you only have 1 carbon. So you have to make this one a 6. So therefore 6CO2. That also means that you'll have 12 oxygen over here. So since you have 12 oxygen plus the 3 oxygen, you got to get this to 15. Although that's not possible currently. So you're going to also have to multiply this. But there's also 12 hydrogens over here. So to get this to 12, you're going to have to put a 6 in front of it. So you have 6H2O. So now when you combine these, you have 12 oxygen and 6 oxygen, so you get 18 oxygen. Now over here, you have to be able to get 18 oxygen. So if we split these up into 2 chemicals, we just have the C6H12O6, so that's 6 oxygen, plus we're going to need to make 12 more oxygen out of 2 oxygen, which is 6. So then 6O2. And then we have 6 carbons, 6 hydrogens, or 12 hydrogens, and 18 oxygens. So that's how you do it. And then it's 6CO2 plus 6H2O equals C6H12. 12O6 plus 6O2. And that's how you balance an equation.